Today's daily code problem of the day is design a stack with increment operation number 1381. For this problem, we are going to design a stack that supports increment operations on its elements. Increment operation basically means that we are going to add a specific amount of a value to each of our numbers. So if we have a stack of 1, 2, 3, 4, and we want to increment each by 3, we'll have 4, 5, 6, 7 instead of 1, 2, 3, 4. So to do this, we can store our stack in an array, specifically because our custom stack is going to have a max size value. This max size value means that there's only a maximum number of elements in the stack, and an array is going to give us the option to set a max size as well as keep track of each element to where we can access them. So we can first initialize an integer array. We'll call it our stack, and we'll have an integer I, which is going to simply be our index. So in our first function, we are going to initialize our stack. So we can have a stack is going to be equal to a new integer array of max size. And then our I value is going to be initialized to 0. So that is how we initialize our custom stack. Now moving on to our second function, we're going to push a variable onto our stack. So this is going to be added to the top of our stack. Again, we have a max size. So as long as I is not equal to stack.length, we can add values onto the stack. So we are going to say our stack of I is going to be equal to x, and then we'll increment I. So I will always be on a empty value. We'll say that. So that adds a value to the top of our stack. We could say we have 0, 1, 2, 3, and then I, and then null, null, null. So we'll look at I, we'll add the value to I, and then increment I to move to the next variable. We're then going to pop. So pop is going to return the top of the stack, or a -1 if the stack is empty. Typically, pop also removes the value from the stack as well. It does not say that it does here, but we are going to assume that it's going to. So if I is equal to 0, in that case we will simply return -1 because our stack is empty. Otherwise, we are going to decrease I by 1 because we already said we're going to keep I always on an empty value. So we'll decrease I by 1, and then we'll return our I value, so stack of I. We do not have to specifically remove the value at stack of I, because whenever we go to add a new value, I will already be in that position to replace whatever value was at stack of I. So that is how we're going to set up our pop function. Finally, we have an increment function. Increment is going to increment the bottom k elements of a stack by a value amount. If there are less than k elements in the stack, we're going to increment all the elements in the stack. So to do this, we are first going to decide whether our k value or our I value is smaller. This is because we only want to increment the k elements at the bottom of the stack. So for example, if we have 5 as our k value, that's 1, 2, 3, 4, 5, I is yet to be determined as a value. So we don't want to pre-increment this value. So let's say if it starts at 0, we're going to increment it by 5 before there even is a value there. We're only going to want to increment the values that we already have at our stack. So we will first, we don't really need to check, we could do it in our for loop. So for int j is going to be our variable. It's going to start at 0. as long as j is less than, we're going to do math.minimum of k and I, j plus plus. So we're going to start at the beginning of our stack and increment each value until we reach either k or I, whatever is smaller. So to do that, we're going to take stack of j is going to plus equal our value. And that's it for our increment. We're going to go through each value of stack and increment it by our value until we either reach the kth value or the ith value. So if we run this, it passes our test cases, and if we submit it, it passes all solutions. So thank you, and follow for more daily LeetCode solutions.